Today we'll talk about temperature and its properties. We'll be able to answer questions like what is temperature and how can we describe the energy at its molecular level. So essentially, temperature is just how hot or cold something is, and we assign a number to it, and we assign a measurement to it. So what has a higher temperature? A cup of coffee or a glass of iced tea? How do we know that a high mark, for example, on a thermometer tells us that it's hot and a low mark tells us that it's cold? What does temperature measure? So we found out that temperature is actually just a measurement of the average kinetic energy of molecules. And we know from last 6 weeks that kinetic energy is moving energy. So based on the movement of molecules, we can tell where something is cool or if it's hot. So if average kinetic energy increases, so does temperature. So when you look at this diagram, on the left, you can kind of tell it doesn't have a lot of movement. It's going to be slow. That means it's going to be a cool temperature. As opposed to if you have hot temperature, we have molecules moving around really fast. And so we know that this indicates a higher temperature. Have you ever been to It's a mosh pit. What's going on in a mosh pit? Using temperature and motion to describe what it is like in a mosh pit compared to watching a concert from a seat. Now imagine all those people in the mosh pit as molecules in a balloon. As the average kinetic energy increases, what happens to the balloon? As temperature increases, so does the average kinetic energy of molecules. So we see that the more kinetic energy, as you see in the right balloon, the molecules are moving faster, and so we know that there's a temperature increase on the right balloon. As opposed to the balloon on the left, perhaps it was left in the freezer, left out in the cold. It is smaller, it's contracting, and the molecules are not moving as fast. They don't have as much energy. They have those little arrows indicating that it has a little bit of energy, as opposed to the right balloon has more kinetic energy. What happens to materials when you raise the temperature? We find that they expand, just like we saw with the balloon, as we raise the temperature. So that's all this means is that as it's expanding, we're increasing the molecular motion. That makes sense because think about all these molecules are kind of fighting as they're moving with all their energy. They're pushing this object further and further. If atoms are moving around more, they tend to bump into each other more, and it takes up more space.
One of them popped. That was kind of scary. Look, I can even hold it. And because I'm holding it, it's actually... Ah! That's so scary when they pop. That's kind of awesome. Well, some of them have popped. There's a big one. Let's see what happens. Will it pop or will it survive? This is so cool. What do you guys think? Go back to normal, no big deal. This is so awesome. Definitely a really cool experiment with liquid nitrogen. And look, it's back to normal. One more time. Look at it shrinking. So cool. It feels like just plastic. It doesn't feel like a balloon anymore. I'm gonna pull it out and put it in my hand. Okay. Let me lift it up, see what happens. Look at it. My hands are warming it up even faster. Wow, look at that side. So my hands are warm, so that's why it's coming back a lot faster. And there you go. A regular balloon. Awesome.
Have you ever seen this on a bridge? Well, this is actually called an expansion joint. So we already know that if heat rises during the summer, if heat rises, then we know that kinetic energy will increase, which means that we will have an expansion. And so we want to be able to close that gap as that happens. You don't want to fall, from the bridge down to the water. And we know that in the winter, heat is going to decrease. That means our kinetic energy decreases, and we're going to have contraction. Okay, we really don't want to have too much contraction. We want to be able to have that expansion so that cars can move freely. Okay, and this is a very special property that civil engineers and even architects can take into account when they're building bridges. Very important. What would happen if you blew up a balloon and put it in the freezer? So now we're going to talk about what is in a thermometer and how does a thermometer work. So based on this diagram, we can see that the kinetic energy on the left is less, right? If we were to draw these arrows, they're very small, as opposed to the ones on the right, they're larger. So you can tell that on the left, your temperature is going to be low and your temperature is going to be high here. And it also happens that as temperature increases, so does kinetic energy. And as temperature decreases, so does kinetic energy. And so now we know when we're looking at a thermometer, if it's low, like this, low, we know that the molecules aren't moving as much. There's not much expansion. As opposed to when it is a little more hot, temperature's going up, we still have the same amount of molecules, but now they're expanding more, right? They have more energy, they're moving more, they're able to expand. All right, so let's talk about pressure and temperature and its relationship. Do you know what pressure is? So I'm pretty sure you probably experienced pressure, maybe when you're sick. So let's say, for example, you try what you see in this picture below. You hold your nose, and while holding your nose, you try to hold your breath. You notice that in your ears, you feel a lot of pressure. And so we know that when you squeeze a fixed quantity of gas into a smaller volume, the pressure goes up. So we just experienced that with if you did close your nose, you experience more pressure. And so why does that happen? As we increase pressure, the same number of molecules are now in a small space. So all of these molecules that we breathe in, and they're all stuck into a little space. They want to move, so pressure increases. Now, this is a big classroom. We have a lot of students. What if we reduce the volume of this class and we all went to the bathroom, or we all went into the stock room, somewhere small? Describe how that would be. So if we're bumping into one another, like molecules colliding, how would that affect temperature? Okay, so let's say, for example, that this diagram on the right represents us in the classroom right now. So we're free to move around, we have some space. So here we could say that our volume is pretty big and our pressure is pretty low. Okay, all of a sudden we have to move into the bathroom, we have to move into a closet for shelter. Our volume decreases, all of a sudden our pressure is going to increase, right? It's going to become very uncomfortable being in a tight, close space. And so this makes sense. Molecules are going to hit around this the walls more often. They're going to be able to touch and collide with one another, as opposed to on the right, they're going to be able to move slower. They have more volume, more space, less pressure. So we say an increase in pressure will result in an increase in temperature, just like we saw on the diagram in the previous slide. And an increase in temperature will result in an increase in pressure. So last year we kind of learned about this a little bit in chemistry, and we taught it through either in the gas laws or through a VT strip, which V stands for volume, T for temperature, and P for pressure. And so this is how this little strip works. Let's say, for example, that I want to see the relationship between pressure and temperature. If I increase pressure, what will happen to temperature? Well, we see that I move pressure up, that means temperature goes up. Okay, makes sense. Pressure goes up, temperature goes up, and what happens to the volume here? As we increase pressure, the volume is going to move down, so volume goes down. What happens vice versa? Let's say I bring pressure down. I want to bring pressure down. What will happen to temperature and volume? Well, let's see. As I decrease pressure, temperature will go down. Okay, but my volume will increase. Okay. So just to summarize again, when we have low temperatures, cold temperatures, the molecules will move slower and we have lower pressure, as opposed to if we have high temperatures, very hot temperatures, the molecules will move faster and we have a higher pressure. That means our kinetic energy here is high, while kinetic energy at low temperatures is low. So finally, there are warning labels on cans of hairspray that say to keep them away from heat. Why? Well, we find out that if you increase the temperature, let's say for example you have your hairspray bottle here, and let's say you have your molecules, they're moving around, you're putting your hairspray in the morning, and all of a sudden you start increasing the temperature. Who knows where you left it, but temperature increases dramatically. All of a sudden these molecules are going to collide with each other, going to hit each other, they're going to keep colliding until your spray can starts to expand outwards, and all of a sudden it explodes. Okay, that's very dangerous, so you don't want that to happen. Okay, so always keep your hairspray cans at an okay temperature. Make sure they're not left in really high temperatures.